Before delving into specifics for blue shifting and red shifting, I find it really crucial to first cover the concepts behind it. In this case, the Doppler effect. So let's do a little thought experiment to start it out. Imagine you're on a busy street and suddenly you hear an ambulance. As it races towards you, the pitch is going to seem pretty high. But as soon as it passes and speeds away, the pitch is going to drop and become much lower. That is the Doppler effect. So let's look at some graphics to understand what is happening here. When an object is stationary, its sound waves are emitted uniformly in all directions. Like the example right here, the waves stack right on top of each other, perfectly spaced. But when the ambulance moves, it will change and look something like this instead. Here, the sound waves in front of the ambulance are going to be squished together because the ambulance is chasing after the waves it emits. Behind it, the waves spread out as the ambulance is racing away from them. This also changes the frequencies, as in front of the ambulance, the siren has much higher frequencies, and therefore it is going to be a higher pitch. Behind the ambulance, because the waves are more spread out, it's on a lower frequency, and therefore a lower pitch. But let's make this even clearer with a simulation. Here is what those waves are going to look like if the ambulance is stationary. As we can see here, it is perfectly uniform, right on top of each other, spaced symmetrically, and this is what's going to appear like, as we theorized before, if the ambulance is stationary. However, in this simulation, the ambulance will be moving, and let's look at that now. In this example, we can see that in front of the ambulance, because it's moving, the waves again are more compressed and behind it spread out, exactly as we stated before. So this bunching up is going to result in those higher and lower frequencies, giving you that higher and lower pitch. Now you might ask, what does this have to do with the red and blue shift? But it has everything to do with it. It just so happens that sound is not the only wave that gets a Doppler treatment. Light does too. So here we have another model where we have Earth on the left and a star on the right, let's say from another galaxy. And that star is going to emit a light wave that travels towards Earth, represented by that arrow. Now, that light wave follows those same Doppler effect principles, as in front of the light wave, those waves are going to be more compressed together, creating a bluer light. You may ask why? Well, here, if you look at our handy-dandy wavelength chart, we can see that the shorter wavelengths have more blue light, and the longer wavelengths have that red light. So if the star is moving towards you, it's going to have a more compressed waves, shorter frequencies, and that's going to give you this blue light. Alternatively, however, if that star is moving away from you, it's going to have more spread out waves, longer wavelengths, and therefore more red light. And if there are more blue light, we call it blue shifted. It has longer frequencies, we call it red shifted. And that's really the distinction between the two. Now you still may be asking, why, what is so important about this? But the reality is that the implications red and blue shifting carries is essential to the universe as we know it. In the 1920s, astronomer Edwin Hubble was finding frequencies from extraterrestrial objects that didn't quite line up with Earth's objects, and he really studied these for long periods of time, and he just couldn't come to a conclusion of why this was occurring. And then he realized that if you take those extraterrestrial frequencies and shift them, shorten the wavelengths a bit, they match up perfectly with Earth's. And he looks at those extraterrestrial frequencies were simply red shifted. And through this observation, he eventually came to the conclusion that it had to mean the universe was expanding because the particles the waves had to be moving away from Earth. So by measuring this degree of redshift, not only did he conclude they were moving away from us, but that the further they were from the Earth, the faster they moved away from the Earth. And this observation provided the foundation for not only the Big Bang Theory, but our understanding of the universe and its ever-expanding nature. So the next time you hear an ambulance speeding past you, recognize that the sounds you hear and the pitches you hear are essential to the very basis of our universe. I hope you enjoyed the video. Like and subscribe. Have a great day.